Hi, I'm Akhilesh Kumar Srivastav. In the previous lecture, we have discussed about how to take input from the user for the graph. We have seen that how to represent the graph using adjacency matrix, incidence matrix, and adjacency list. We have done a very small code for taking the input from the user and representing it in the form of the adjacency list. We are going to extend the same concept in this lecture, and we learn how to traverse the graph using the BFS. So let's say this is a graph and we have to perform the breadth first search on this graph. For doing so, we need to have the adjacency list. So let us first draw the adjacency list and we'll solve this for finding out the BFS. So the simple representation here will be connection from 0, 1, 2, 3, and 4. From 0, the connections are 1 and 4. From 1, the connections are 0, 2, 3, and 4. From 2, the connection are 1 and 3. From 3, the connection is 1, 2, and 4. And from 4, the connections are 0, 1, and 3. For doing the breadth first search, it means we are going to explore the vertices, all the vertices connected to a vertex at a time. So for doing so, let us maintain the status array or status vector, which will be representing the status of each of the vertex. If a vertex has not been visited, its status will be 0. And if a vertex has got visited, its status will be 1. To initialize with, we will take the status of each of the vertex as 0. And this is the direct address table. The status array or the status vector is the direct address table, wherein at the 0 index, we are representing the status of 0 number vertex. At 1 number vertex, we are storing the status of 1 number vertex, and so on and so forth. We also need to take a queue which will store the current explored vertex. In case the source is not given in this graph, we can consider 0 number vertex as a source and we push it on the queue, or we insert this on the queue and mark its status as visited. It means when a vertex comes to the queue, its status will be marked as visited. Then we delete this vertex 0 and try to find out the connection from 0. So from 0, the connections are 1 and 4. One by one, let's see if they have got visited earlier or not. So 1, the status of 1 number vertex is 0. It means it has not got visited earlier. So let's mark its status as 1 and push it on the queue. 4 is also 0. It means 4 has not got visited earlier. So the status of vertex number 4 is 1 and this has got pushed on the queue. Now let's delete the vertex number 1 and let's see the connection from 1. From 1, we have 0 number vertex, which has already got visited. Its status is 1. 2 has not got visited, so mark its status as 1. And let's insert this on the queue. Vertex number 3, this has not got visited earlier. So let's mark its status as 1 and push it on the queue. 4 number vertex has already got visited, so we will not push it again on the queue. It has already got visited. Now let's delete vertex number 4 and let's see what are the connection from vertex number 4. So the connection from vertex number 4 is 0, which has already got visited. 1 is also got visited. 3 has already got visited. So we will not make any further connection from this in the queue. Let's delete 2 and the connection from 2 is 1 and 3. Both of these vertices have already got visited, so we will not include it further. Now, vertex number 3 is deleted from the queue, and the connections are 1, 2, and 4. 1 is visited, 2 has already got visited, and 4 has also got visited. So we have seen the connection from 3, and the queue is empty. It means that my process has got ended here, and the order in which I have inserted the data values in the queue, vertex in the queue, that is actually the BFS order. It means The BFS order is 0, 1, 4, 2, and 3. So this is the order in which the vertices have got visited. Let's try to write a simple algorithm for the same. Let's say BFS is the algorithm given to us, or we have to write a graph is given to us in which the adjacency list is given to us. So let's say adjacency list is given to us, which is the array of vectors. If you are representing it simply, we can say that this is a 2D array. A source vertex is supposed to be given here. If not, then we will consider vertex number 0 as the source. One more entry, I think it should be here, which is the number of vertices. Let's say V is representing the number of vertices. So what we need to do from our side, we need to take the status vector of size V and let's initialize all its values to 0. This kind of initialization does not actually means that we are initializing all the values to 0. It means we are initializing first value as 0 and rest of the entries will automatically be initialized to 0. Now, we will insert the first vertex in the queue. It means, let's say if we have a queue, we will insert the source vertex in this queue. Before this, we need to take a queue named as queue. And this queue will be initially empty. Now, what next we have to do? We have to process the things in a loop. So by the time queue is not empty, so while not is empty queue, we will have to take one value from the queue. So let's apply a dequeue function, which will give us a data value queue, which will be at the front. We have to see all the connections from this X. So for each J that is adjacent to X, what we'll do, we will see the status of J. If the status of vertex number J is 0, it means this vertex has not got visited earlier. So we will have to visit this. For visiting this, we will mark the status of this vertex J as 1. And we will insert this vertex J in the queue. Once we have seen all the connection from this vertex X, we can print the data value of this vertex. And in sequence, the deleted data values from the queue will be printed in that order. So this is a simple algorithm for BFS. Let's try to write a simple code for performing the programming of the breadth-first search. So this was the code that we did at the last time for the representation of the graph. We will extend it further to work as the breadth-first search. Now, for doing so, we will have to take a queue. Since we are going to insert the vertex numbers, so the queue will be of the integer type. Let's name it as queue. We need to take a vector of integer type, that is status. The size of the status vector will be n, and all the data values will be initialized to 0. Even if you do not write 0, it will work because the default initialization is 0. Now here the source vertex is not given, hence we'll insert the vertex number 0 here. And then by the time the queue does not become empty, while not, or you can write that queue dot size is not equal to 0, first you will have to take the front value from the queue in some x variable, let's say, and then we have to pop this value. After this, we have to see all the connection from this x. So for integer j equals to 0, j less than adj list x dot size and j plus plus. So for each of the vertex which is adjacent to x, let's say the adjacent vertex is y, and y is equals to adj list xj. We will have to check the status of vertex number y. So if the status of y is 0, it means it has not got visited. So mark the status of vertex number y as visited and push this vertex y back in the queue. So by the time there are the connections from this, it will perform well. And after this, we will print this vertex number x and a comma also, which will just to make a differentiation between the different vertices. So by the time the queue is not empty, this will work. And the moment the queue becomes empty, it will come out of this loop. So there are some of the things we are missing. Let's try to mark those things. Let's say we have to use a queue. So we need to have a queue header file here. I think the rest of the things should work fine. Let's take a quick review. We have taken a queue. We have taken a status vector of size not n but v. Here the number of vertices are v. We have pushed the 0 number vertex in the queue, and by the time queue has the element, we'll perform the deletion from the queue, and then the connections from this vertex number x is explored. If that vertex is not visited, let's visit that and push that vertex in the queue. Finally, when we have seen all the connection from x, we can just print the vertex number x. Fine, let's try to run this. So here we are going to take the same graph that we took, and the number of vertices here are, let's say, 5, and the number of edges are 7. The edge number 1, I'm starting from 0 number vertex. So the 0 to 1 is considered as the first edge. So 0, 1. Second edge is 0, 4. Third edge is, let's say, 1, 2. Fourth edge is, let's say, 1, 3. And the fifth edge is, let's say, 1, 4. Then the sixth edge is, let's say, 2, 3. And the seventh edge is, let's say, 3 and 4. Okay. So you can see that first, this is printing the adjacency list here. And then we have the BFS order. I think this was the order we have seen in our numerical example, 0, 1, 4, 2, 3. I'll just verify it, 0, 1, 4, 2, 3. So I think we have coded well, and I hope you must have understood how to code for the graph and how to code for the breadth first search. Thank you so much for watching this video. We'll meet again in the next lecture with extension of the concept of the breadth first search, wherein we will try to find out the shortest distance between the source and the defined vertices. Thank you.